We have been working in this general space really for quite some time, and we do have a little more flexibility at a CSU than they do necessarily at UC. I love all of our UC partners. They're wonderful to work with, but we do have a little more latitude, and that does help us to kind of move around in some different places. When Jason asked me to be on this panel, he said, now what we would like you to do is 3 slides, and so he gets 10, and not just with me. All the other lovely ladies on this are also in that neighborhood. He said, well, we need you to really kind of talk about 10 minutes. Well, he's getting 15. That's kind of how that works out. So we may go a little over, or I will talk very fast so we can get this, get the rest of the panels up on the screen. The initial question is this: what is our biggest issue? What's the biggest challenge? And he didn't necessarily say from a research perspective. You know, so we gave that some thought. And there really is only one big issue that's the biggest issue. You know, the planet's heating up. I mean, we've got some serious global environmental issues going down. And we need to be able to embrace it. And this is really the group of people who can really address it. I hate getting gloom and doom, and I know that people tend to shut down with that. But we also don't want people to become complacent. So how do we engage in that dialogue in a meaningful way? You know, not to offend people, but you know, to bring them to the table and talk about some of these different types of practices. Well, usually with the farmers, I tend to engage them more on economics and soil quality, production, that type of thing. And when I'm with kind of an environmental group, I can really dive into carbon sequestration, soil carbon, from that end. So it really depends on what group we're working with. But this, to me, is the biggest issue. And to ignore it, I think, is really not a place where we need to be. I work in the College of Agriculture. I have a lot of students that come from agriculture, and they're really not even in this whole paradigm. To them, you know, this is not happening. It's non-existent. So it's important that we kind of bring this dialogue to them. We need to wake people up. They need to know what they don't know. And so we do talk quite a bit about some of the problems that we have. And frankly, agriculture can be part of the emissions problem. And you know, in my world, there's a couple of different kinds of students. There's the students who actually get angry at that kind of dialogue. You know, how dare I talk against agriculture? I was born and raised in ag. All my family farms, both sides of my pedigree from the heart of Illinois. There is nothing about farming. I mean, that's my life. That's my people. So I'm not talking against it. I'm not talking against, but we have problems that we need to embrace. There's no sense in ignoring the problems. I mean, we've created some situations that we need to adjust. And agriculture can, in fact, you know, be part of the problem. Tillage is one of the biggest, enteric fermentation. We've got manure management issues, particularly those of us in the dairy industry, feedlot industry. Forest fires, we don't necessarily control ourselves, obviously, but we have some issues that we need to address. On the other hand, agriculture is in a very unique position to be the solution to those same issues. And now that we're getting into more of the science, and there's some wonderful greenhouse gas scientists on this panel that can kind of talk in detail about the fact that many of these systems can actually become a carbon sink. So, you know, in isolation, or if we were just to take and pluck that cow out and look at her independently, she might be a net greenhouse gas emitter. But when you put her back in her ecosystem, on grass, on soil, where she's part of that whole biome, she actually becomes a carbon sink. She feeds the soil creates the microorganisms that sequester the carbon. So it's a systems-based research paradigm that is really the future in production agriculture. So this is, I spend a lot of time talking about this kind of thing, especially with my students, because they often kind of come to us with a certain paradigm in mind. This is how we farm, this is how we've always farmed. So we have to spend some time unlearning that and relearning a new paradigm. Because frankly, and I tell me, if you're going to be farming like your grandfather farmed, you probably aren't going to be farming for very long. Hard as that might be to hear, the fact is ag's a very dynamic business. And some of the most successful farmers that I know of that have transitioned from mom and dad or from grandma and grandpa are really farming in a whole different paradigm now. Not only are they producing corn, wheat, or cattle, or milk, but they're also doing other kinds of things in order to generate more off-farm income. They're thinking about carbon farm plants, and so they can actually get paid for the carbon that they're sequestering in the soil. They're thinking out of the box. They need to think new thoughts. Scientists are really doing the same thing. I came through a lot of the land-grant institutions where I had done my work, and we're really taught how to do research in a very specific way. We get an idea in our mind, and then we go out and we set up an experimental design to study it. Today, I think it's probably going to be more productive for production agriculture is that we really look to those farms that are doing it well, and then study that ecosystem and figure out why is it working so well. And that's the paradigm that actually happened, with the Gay Brown farm. Chris Nichols, many of you probably know her. She's quite the agronomist. She does a lot of work in this arena, and she went to Gabe's farm because he was so productive. Not only was he working financially, but he was also sequestering carbon like crazy. This diagram actually shows his transition over time. So this is Gabe's learning curve, so to speak, where he began in 1993, and you can watch his soil carbon over time as he began to learn new thoughts and implement new farming techniques, like no-till. Adding in some crop diversity, using cover crops, multi-species, using polycultures, and then he brought some livestock in, and that really sent his soil carbon through the roof. Now, that's not necessarily the kind of thing that turns farmers on. They're more interested in the economics. Well, that's when his profitability started to soar as well. Now he had a transition plan. He could bring the kids in. He could afford to bring the kids in. And they were doing different aspects of the farm. We had different enterprises that were all equally profitable. And he was just about going broke in 1993. So not only does this work environmentally, but it also works economically, which is obviously incredibly important. So this is really where science is going, is trying to find these kinds of situations where we know that the agricultural production system is working. That system is working, and farmers are the most innovative people I know. They're pretty inventive, and they're doing some pretty interesting things. So we kind of use that same model for a USDA innovation grant that we won in 2018. It's a consortium between UC Davis, Fresno State, and Chico State. And we're working together with 5 really innovative farmers that already have a lot of regenerative ag going on their farm. And what we're going to do is help them conduct their own research and then help them understand what changes happened and why they happened, so that we can then teach other farmers the same kind of a thing. Vegetable cropping systems are probably one of the most highly tilled cropping systems there are. So if we were able to come up with a system of no-till in vegetable cropping systems, then we would have something. It's a big crop here in California, as it is across the states, but by and large, these are the guys that we're working with. These are some pretty incredible folks. They've been farming for several generations. Many of them have sons now and daughters that are working in their farming operations. So each one of these gentlemen have devised their own on-farm research program, and it's focused somewhere around tillage, minimum till, strip till, conservation tillage in veg crop. So hopefully in a couple of years we'll have something really meaningful. We're capturing it all on video so that we can kind of give you a chronological evolution, not only of their farm, but also in their thinking. Because that's really, I think, an important aspect of this paradigm shift. And how do we get people to engage in a new production practice? How do we get more people to engage? Other things that are going on within our program, the Regenerative Ag Initiative at Cal State, we're doing some work with David Johnson. How many of you have heard of the beam reactors? Oh, yeah. So you may want to go on our website. We've got a beam registry, and the whole idea with that registry is that we can kind of help producers do it well. And David is committed to making sure that you're doing it well, so we'll have a listserv up and going very soon, and we want to make sure that everybody's beam after 12 months of incubation is a 5-to-1 fungal to bacterial ratio. That's kind of a critical piece. So we want everybody to be successful there. Anyway, we're working with seed inoculation. So we're using some of this fungal-dominated inoculum, and we're inoculating some cover crop seed, and we're using that seed out on rangeland, which is notoriously bad soil. I mean, with a soil organic matter of about 1.5, it's pretty bad stuff. In the summertime, it takes a jackhammer to get down 6 inches. So that's pretty tough soil. So what we're hoping we can do is make some improvements there, enhance the overall productivity of that land by generating more forage, more high-quality forage for cattle grazing, but also improve the soil and sequester carbon. So that particular study has 4 different treatments, where it's just a regular rangeland control, which is nothing more than the normal annuals that tend to come up. You know, we can't really call them natives because Richard King's in the audience, and he'll correct me and tell me that those aren't really native species. They are, in fact, annuals that have been invasive. We're going to contrast that against a cover crop seed at about 60 pounds per acre, and a third treatment where we inoculate that same seed with a fungal-dominated compost to determine whether or not that biology is going to enhance the overall germination rate and the overall productivity. Because theoretically, at least the hypothesis is that by adding the fungal species, that fungi will help feed those plants, and that we should see deeper root systems and more productivity, but until we do the work, we really don't know that. As a fourth treatment, because we think that we needed to have another control, we're using regular compost, windrowed compost, aerobic windrowed compost that's heavily bacterial dominant, and we're inoculating seed for that as well. So we've got 4 treatments replicated 3 times on 3 ranches. So we've been busy, and that's where I was yesterday. Everybody's given me a really bad time about not being here yesterday. But that's where we were, collecting data. We're dutiful. Another aspect of what we're doing is we're creating a journal for regenerative agriculture where we can actually publish, doing peer-reviewed work, this systems-based research that's out there. It's really kind of a paradigm shift for many of the journals. They just don't accept it because they don't understand it. So we're hoping that we'll be able to put this type of research, if you happen to know of folks that are doing some types of research that is replicated and statistically evaluated, has a nice experimental design, you might want to send it our way, and we'll put it through our peer review process. We're working through a program called Scholastica, so it's all online. It's really quite slick. And we'll send it out for peer review among other types of scientists that are also doing similar work. We're also accepting articles from farmers on farmer innovation, so if you happen to be doing something really interesting, and you've got enough data to back it up, we really encourage you to submit those articles as well, and we have a farmer review panel that's going to be looking at that information to determine whether or not we'll publish. We're also going to be doing some research briefs because there's a lot of work that's going on out there that maybe 2 or 3 years in, it's not quite finished, that we would really like to get some kind of preliminary data on. So that's another aspect of the work that we're doing with the Regenerative Ag Initiative. So our group is a consortium of many faculty from all disciplines and from across different colleges and with different institutions. We're also working with other NGOs. We're also working with many different organizations to kind of bring a lot of this programming really to our students and to the industry and to farmers. So our mantra is we educate, we investigate, we actively engage, and then we facilitate shifts in paradigm.